Hey guys, welcome back to Consistent Code. So today's problem of the day is minimum swaps. So now if you want you can read whole of this problem statement, but I'm going to explain this to you in a simpler manner. So let's get to it. So this is the problem statement. You're what the problem says that you're gonna have like five sheeps n will be the number of sheep you have. So in this question we are having five sheep, so which I have marked with the orange color. So the sheep's position have been given to us. This is in this position array. So it is at position 0, 2, 5, 6, and 7, and the velocities of sheep. All the sheep are moving towards the right direction. So and the velocities are marked given in the velocity array in the input uh, in this velocity array. So I mark these velocity here in this brown from this brown color. So as you can see in and the destination is this capital B, which is 10. So I mark that with this green color. So basically we have five sheep in the sample input and their speeds, their positions, and the position where they need to reach. Now the question also says that there is this two more inputs which we need to know what they are given for. For example, we are given k equals to 3 and t equals to 5. So what are they given for? So what we need to do with these shapes? We need to find basically this t is the time which we need to consider that how many sheep can come to the destination, which is 10, in this time, or in time capital T, that is either in 5 seconds or less than 5 seconds. How many sheep can reach the destination? This you can, this is what the question is saying, but this is not the complete statement the question is saying. The question is wants to ask that what the question has also given us k equals to 3. That means that we want to um, know that at least k sheeps, that at least 3 sheeps should be able to reach the destination in time less than equals to a given time capital T. So in less than equal to this time, at least k sheeps should be able to reach the destination. If this is the condition, then we need to perform the minimum number of swaps on the sheeps. Now, what are these minimum number of swaps? So, what are these swaps? So, basically, what this swap is, suppose the question is saying that consider there are three sheeps. Okay, suppose you are having three sheep, right? This is one sheep, this is two sheep, and this is third sheep. And let's say you have a destination. Suppose this is the destination. Now we know that this sheep, suppose this sheep is having a velocity of 2, this sheep is having a velocity of 3, and this sheep is having a velocity of 4. So what the question is saying that if this sheep, uh, you can say this third sheep, there will be a time when this sheep can overtake this sheep too, right? But the question is saying if this sheep reaches this sheep too, then it will travel with the sheep only. That is, it will not overtake this. It will start with this, and its speed will be converted to you know this, its speed will be changed from 3 to the speed of the sheep which it has reached. So now they will both will go with speed 2 to the destination. So this is what the question is saying, right? So if this sheep with speed 2 can reach the destination, then it's okay, we can consider this third ship to have speed 2 and reach the destination with this ship. But what if this ship 2 cannot reach the destination? If this ship cannot reach the destination and this third ship is able to reach the destination in time less than equals to t, obviously ship 2 can also reach the destination, but maybe consider the case when this ship 2 is taking uh, in the ship with speed 2 is taking time greater than this given time t. So in that case, when the ship 3 and ship 4 will come to 2, they will also move with speed 2 only. So they will also not be able to reach even if they can reach with their current speeds. So this is why we need this swaps. So what is a swap? We are allowed to perform operation that we can consider this 2, we can drag it and drop it here, that is so that ship 3 can pass below the ship 2 and ship 3 can continue moving with speed 3. So now ship 3 will be able to reach. Similarly, we can swap 2 and 4. So ship 4 will also continue moving in the forward direction and they will both reach the destination with their speeds. So this is what we need to do. We need to find the minimum number of swaps. So we need to find the minimum number of swaps required. And also if it is not possible that at least k ships can reach in less than equal to time t, we need to output -1. So what we can try out in this question. See, there are some observations which you can observe. First observation is, if this like in this case, if sheep 2 is not able to reach the target and suppose this sheep 2 was initially here. So in this case, if sheep 2 is unable to reach the target, we need to swap this sheep 2 with all the sheep which can reach the target with their current speed, with all the sheep which can reach the target. But suppose this sheep 2 was originally in between these 4 and 3 sheep. So now sheep 3 can easily reach the target because there is no sheep in between it which can slow it down. But sheep 2 will not reach the target obviously, and this sheep 4 can reach the target with speed, but since there is sheep 2, so we will need to make a swap with sheep 2 and then sheep 4 can reach the target. But now there might be a question in your mind, and what if sheep 4 reaches sheep 3, then its speed will also be slowed, right? So in that case, even if its speed does get slow to let's say its speed gets reduced to say 3, then we know that sheep 3 is able to reach with its current speed. So even if its speed is reduced to 3, they will both reach their destination successfully. So hence from this observation, we can now start writing our code. So what we need to do, first of all, let us create a variable to count the number of sheeps which can reach the destination, and let's create a variable to count the number of swaps we will require, right? So now what this count variable stores, this count variable will store the number of sheep which can reach the destination with their original speed. And now we need one more variable that will store the number of ships. For example, in this case, uh, suppose 2 was here and these two were here. So we need a variable to store the number of sheep. Suppose now we are at this sheep, this cannot reach, so we want a variable to store this number, so we can store this variable as um, bad sheeps. So we can say bad sheep is 1 here. Now when we will move to this position, to here at position, sorry, at this sheep number 2 and this sheep, then we need to check how many bad sheep are in front of this, so we need to swap this sheep with all of the bad sheep, so we need to swap it with one sheep. Similarly, when we move to this sheep, we need to swap this with all the bad sheep present in front of it, so we need a variable to store the bad sheep. So currently we are having 0 bad sheep. Now we can start our for loop with the last position, that will be n minus 1 to I greater equal to 0 and then I minus minus. So we are traversing from the last position. So if I consider the our original question, so we are starting from this last position, and we will check if this is able to reach the current position. So how to check that? If it is given time capital T, right? If it is given time capital T, then how much distance can this sheep cover? So that distance d will be equals to that capital time T time multiplied by the its velocity, which is 4. So that will be equals to 5 into 4, which is 20. So it can move 20 meters. And how much we want it to move? We want, that is, we required is only 10, which is the destination, minus its current position, which is 7. So we only require it to move 3. Hence, since we have its capacity of moving greater than its requirement, so this is a good sheep. Hence, we can move on to the next sheep after this. So this sheep will reach the destination successfully, and now we need to check for this sheep. So in this case, what will be its d? Uh, that is the how much it can move. That will be t into 1. So in this case, d will be capital T into 1. That is equals to, since capital T is 5, so I can say 5. It can move 5 meters, and the requirement is 6 minus how much? Uh, Sorry, 10 minus 6. So the requirement is, let me write it. So the requirement is 10 minus 6, which is equals to 4. Since we can move more than required, then this is also a good sheep. So they are both good sheeps. Now we need to consider this sheep number 5. Um, so now this sheep, if we see, then this sheep can move 1 into 5, 5 only, right? 5 distance it can move, and its requirement will be 10 minus 5. So its requirement will be 10 minus 5, that is 5. Since we have distance which we can move uh, equals to required, this is also a good sheep, so this can also move. And now you can see that we wanted at least 3 sheeps which were able to reach the destination. So we are having these 3 sheeps, hence we do not need any swapping required. We don't care now the rest of the sheep reach the destination or not. So now we are going to code this thing up. So first of all, what are we checking? If it is good or bad. sheet, right? So how can we check that? We need to check if capital T into the velocity of current sheet is how much, and this will be the small d, right? And what will be the requirement is uh, greater or equal to the requirement. And what is a requirement? Requirement is the destination, which is b minus its current position, so b minus ci. In that case, what I can say, this is a good shape. It is a good shape, so I can say I have got count plus plus for the sheep, or so yeah. So I've got count plus plus, and what else I do need? What else I need to update? We are not going to make any swaps, or I should say, we need to make some swaps. How many swaps will we make for this good sheep? By the number of bad sheets in front of it. Now currently there are zero bad sheets, but if there were any bad sheets, we would be making swaps equals to the number of bad sheets, right? So, and now let us consider case if it is a bad sheet. So in the else part, we can say bad plus plus. That means this is a bad sheet. And also, if our count is greater or equal to k, if we got k ships uh, reaching the destination, what I can say, I can say that I can break this loop, because then I don't care about the rest of the sheets. Now, and what I can return here, so first I will check if the number of sheep which are reaching the destination is greater than or equal to k, then we will return the number of swab we required. Otherwise, we can say that it is not possible and return -1. Great. So now let's try compiling and running our code. So it's working for this input. Now let me check for this another input. So let's check this for input also, and we are getting the correct answer for this case also. So let's try submitting this code. So we have solved the problem successfully, and I hope you like this explanation, and if you did so, make sure you hit the like button and subscribe to the channel for daily problem of the day and other contest problems, and I'll see you next time.